Guys, it's the Educator. Welcome back to my channel, and in this video we're going to be treating some revision questions for PHY111, and this video has been divided into three parts basically. Okay, so do well to watch the three parts. In total we're going to be looking at 150 revision questions. Now you will agree with me that PHY111 is actually divided into two sections. We have the theoretical part and we have the practical, or rather the calculational part. Okay, so the calculational part, I've made a concise material for that, and I'll be granting access to those who watch this video. The access is totally free. You're not paying for it. It's not a paid material. So all you need to do is just watch this video. As soon as you are done with watching the three videos, you will be granted access automatically. But these videos we are going to be treating are purely theoretical questions mixed with formulas. Okay, so let's dive into the video. Now before we dive into the video, please ensure that you are a subscriber to this YouTube channel. If you are watching this video and you are not yet a subscriber, please do to hit the subscription button while we get started. Alright, question 1. Which of the following forces act between two electrical charges? Electrical charges, of course, you have your electrostatic force, electrical. Okay, question 2. Coulomb's law describes the force between two electrical charges. Okay, so when you hear electrostatics, the law that should come to your mind is Coulomb's law. Alright, and you should know what the law states. Okay, the force between charges. Alright, question 3. The electrostatic force between 2 point charges is directly proportional to the dash. You can see we are still looking at the law. This is just 3 different questions answering one law or explaining one law. So it means that if you don't know one law or this law, it automatically means that you're going to fail the 3 questions. So it's very important that you put all these things into consideration. Alright, so moving on, question 4. According to Coulomb's law, we are still under Coulomb's law. You can see, according to Coulomb's law, the electrostatic force between 2 charges decreases as the square of the distance between the masses increases. Now you might want to ask me, why is one increasing, why is one decreasing? Now you also agree with me that in the law there's something that happens. There is an inverse proportion. Okay, the product or the force, the interaction between two forces, is inversely proportional to the square of the distance. So you see Q square, or you see R square if we were looking at gravitational force, as radius. Okay, so if the force is increasing, of course the square of the distance between the forces or the charges will decrease. So it's an inverse proportion. Take note of this. Question 5. Two charges having the same sign will repel each other. This is a very common question. In fact, this question is also going to reflect in magnetism. Electromagnetic induction is also going to reflect there. Two charges, positive will repel. So unlike charges attract. So just take note. Okay, this is another question still saying the same thing. Two charges having opposite signs, of course, different signs, attract. And that is why you get attracted to a boy as a girl and get attracted to a girl as a boy. Not getting attracted to a boy as a boy is an error. Okay, so just use that to remember. Question 7. The SI unit of electric charge is the coulomb. That's the SI unit of electric charge. Alright, moving on. The principle of superposition states that the total electric force on a charge is the vector sum of the individual forces acting on it. That's the law of superposition. You add the sum of the individual forces, the vector sum. Alright, question 9. The electric field at a point is defined as the force acting on a unit positive test charge. Question 10. The SI unit of electric field intensity is Newton per coulomb. Okay. Question 11. Electric field lines originate from positive charge. This is a very common question that you should not miss out if you eventually come across it. Okay, if you eventually come across the questions on the day of your exam, take note of it. Where does electric field line occur? Electric field line occurs from positive charge. So electric field lines terminate on negative charges or infinity. So they originate from positive, terminate in negative. The electric field inside an ideal conductor in electrostatic equilibrium is zero. Equilibrium, positive, negative combining, or positive, negative are equal level, 0. Take note of that. Now, Gauss's law. This is in fact, you should expect Gauss's law. Gauss's law is something you should expect. Gauss's law relates electric flux through a closed surface to the charge enclosed by the surface. Now, you should not only use this video to just learn questions that might come out. Of course, you can also use this video to practice. So once you see the next question, try to answer the question. You can pause the video, try to answer the question, then play it and get the answer. And see, by doing this, you are also preparing yourself for the exam. Don't just solely use the video to just be watching and be learning and be expecting questions. Okay, you can use this video to also revise and see how prepared you are for the examination. Electric flux is a measure of the amount of electric field passing through a substance. The SI unit of electric flux is Newton meter square per coulomb. You can see we have done 3 SI units just now. Please, all these SI units, take note of them. It is very, very easy to mix them up, and I beg you, please don't mix them up. Know which is which. Alright? Gauss' law is particularly useful when the charge distribution possesses suitable symmetry. Alright, next question. An electric dipole consists of 2 equal and opposite charges separated by a distance. This is a very, this question is a common physics question in secondary school or JAM. If you are going for JAM, you most likely know this question. Electric dipole. What forms? This question can be asked another way. Tell you what forms an electric dipole. An electric dipole is basically 2 charges. These charges must be opposite charges, and they must be equal, and they must be separated by a distance. That is a dipole. As simple as that. The electric dipole moment is directed from the negative to positive. Alright, so the SI unit of electric dipole moment is coulomb and meter. An electric dipole placed in a uniform electric field experiences a torque but no net force. The torque on an electric dipole in an electric field tends to align the dipole with the electric field. 23. Electric potential at a point is defined as the work done per unit positive charge in bringing it to that point. Electric potential. The SI unit of electric potential is volts. Take note of that. Electric potential is volts. The potential difference between 2 points represents the work done. You can see the same question, but they change the question and in a way change the option. So if you are not careful, you miss a question that you understand. Okay, so it is the work done. Alright, the work done per unit charge in moving a first charge between the points. Alright, 26. An equipotential surface is one on which the electric potential is constant. When you hear anything equipotential, that's potential in equilibrium. So the potential is constant, the electric potential is constant. The electric field is always dashed to an equipotential surface. It's always perpendicular. Alright, 28. A capacitor is primarily used to store electric charge and energy. Capacitance is defined as the ratio of charge to potential difference. The ratio of charge to potential difference. Charge to potential, Q over V. 30. The SI unit of capacitance is farad, of course. Farad. 31. Direct current is a current that flows predominantly in one direction. That, of course, direct. Ohm's law states that at constant physical conditions, current through a conductor is proportional to its potential difference. The mathematical expression of Ohm's law is V is equal to IR. Of course, the SI unit of resistance is ohm. Electric resistance of a conductor depends on its length and cross-sectional area. You know that formula. You should remember the formula. Okay, resistance equals to PL over A. Cross-sectional area. Then you have the resistivity. You have the length as well. Length. Okay, these things affect the electrical resistance of a conductor. For uniform conductor, increasing its length generally causes its resistance to increase as well. If you look at the formula, you have R is equals to L over A, which means R is directly proportional to L. So if R, which is the resistance, is increasing, length is increasing, you're also increasing length. If you're increasing length, the resistance is also increasing. But if it's cross-sectional area, what will happen? It's inverse. So if you increase the cross-sectional area, you are decreasing the resistance. These things are simple mathematical expressions. 37. Increasing the cross-sectional area, okay, you can see, of course, the same question, decreases. In a series circuit, the current through each resistor is the same. Please take note. In series and parallel, there are 2 things that you take note of. You take note of current and you take note of voltage. Okay, but as we proceed, you'll see more questions. So in series, the current is the same. The current is the same. You should know what series is now. Where you have, this is a series connection. Okay, the same. The equivalent resistance of resistors connected in series is the sum of their resistance. Okay, I see in series you just do R is equals to R1 plus R2. Remember that, right? You just plus them. Okay, you just plus them and you get the total resistance, or you get the resistance equivalent. 40. Now in a parallel, now watch, in a parallel the potential difference is always the same. You can see in series it is the current that is the same. Now they can change the question. They change the question. They now say potential difference is what? Is different. If the current is the same, potential difference will be different. If potential difference is the same, current will be different. Please take note of these two. They can be confusing at times, but please, I beg you, make sure you know this thing very well. Know it and know peace. From this question, you can see, from this concept rather, you can see 4 questions already. Have like 4 questions from this concept, which means that if you eventually see this on the day of your exam and you mix them somehow, you have failed 4 questions, and that's 8 marks gone for just a very simple concept. It can be confusing at times, so please take note of them. Very important.